Welcome to Let the Quran Speak. I'm Aisha, your host. In our series on biological evolution, we'll begin our discussion by outlining the theory of evolution itself. Before we can figure out how evolution aligns with the Islamic understanding of human life, we need to take some time to unpack the evolution theory itself. Let's start this exciting conversation with Dr. Shabbir Ali. Welcome to the show, Dr. Shabbir.
Pleasure to be on.
So we're talking about biological evolution, and on our segment today, we'll focus specifically on the scientific theory. So can you contextualize it for us a bit?
Yeah. First, we need to understand the theory well and understand it from scientists themselves, because there's a lot of misinformation out there, especially coming from persons who just simply want to attack the theory and prove it wrong. And I should add that I was of that category at one time too. When I first started preaching Islam in public, I gave lectures trying to denounce the theory and find holes in it, prove it wrong. But the more I studied the theory from books written by experts in the field, I came to understand it better. So even what I want to say now should not be taken as a replacement for studying the theory from the known experts in the field. But as a preface to discussing the religious view, we can just make a few brief observations about what the theory is. So basically, as we all know by now, the theory started out with Charles Darwin and the observations that he made when he voyaged on the Beagle to South America and to some of the islands around that region. He noticed the variety of species, of birds in particular, and more generally, he thought about the reason why species diverge from each other. While they share certain similarities, they have certain differences as well. And why do these differences occur? And he wrote his book entitled The Origin of the Species. I have a copy here, Origin of the Species. And I wanted to share with our viewers his conclusion to the book. I want to show that, in fact, the way he concluded his book shows that he was not anti-religious, and he saw his theory as meshing with the idea of a creator. But to him, the creator, rather than create each species individually and separately, he breathed life into some original forms, or one original form, and then allowed that to evolve over time with the passing of the ages. So this is what he says, basically the last sentence of his book. It's a long one, a long sentence. He writes, "There is grandeur in this view of life, with its several powers, having been originally breathed by the Creator into a few forms, or into one, and that, whilst this planet has gone cycling on according to the fixed law of gravity from so simple a beginning, endless forms, most beautiful and most wonderful, have been and are being evolved."
So are you saying because of the way he's positioned it, the way he's wrapped everything up, that there is possibility that this theory could somehow balance itself out with how we see religion?
Yes, of course, even if he hadn't said it, there are scientists now and people of religion who are seeking a convergence of the two streams of thought here, scientific view on the theory of evolution, religious view that God created the universe. But the fact that he said it already shows that from the inception, it was not conceived of as a theory that needs to exclude God. And often the debates about this seem to come from that angle. It's either you believe in the scientific theory, in which God is out of the picture, or you believe in God, in which case you cannot believe in the scientific theory. And what I want to project in this show is that, in fact, one can find a harmony between the two, but where the harmony lies and where the differences may exist, these are the details that we will need to discuss.
Now, obviously, the evolution theory didn't stop with Darwinism. I'm sure it's evolved over the years. So based on your research, what can you share about how it's evolved?
Yes, 150 years later, we have accumulated a large body of data from many scientists studying this from many different angles and bringing many disciplines together to comment on this issue. There is the rise of genetics, for example, and with genetic science we can trace, we look at a baby and we say this baby has got his grandfather's eyes or his mother's lips and so on. But then we can go further and say maybe there is blue eyes was a few generations ago it was a recessive trait and then it suddenly reappeared in a later generation. Well, more than this, geneticists are able to trace an individual back many generations. And so with this kind of science in mind, we're looking at the way in which the genes change and evolve over time. So that's one area that has been brought to this, and many other areas of science.
So with that genetics point, is that also alluding and reinforcing the idea of evolution?
Yes, all of these various areas actually confirm that evolution does continue. Denis Venema, in a book in which he co-authored entitled Adam and the Genome, has likened genetic studies and the evolution of genetic material to the evolution of language. Languages change over time, and in fact, our genes are coded with certain letters that scientists use to represent the various chemicals, A, C, G, and T. Mm-hmm. And basically, our chromosomes have some 3 million such letters. In each, so you of each of 2, so you have like 6 million altogether. That makes a very long sequence, and no 2 sequences are identical. That's why we can pin a certain person to a crime scene based on his or her DNA, because that's a very unique. That's better than fingerprint in a way. This way allows us now to trace the evolution. We can see that there are genetic mutations from one person to another, from one generation to another. Even with identical twins, you have a difference in the DNA from one to another, though the differences are subtle, but the differences are there. So this allows you to trace a family tree and to see where differences have occurred and where people have branched away from each other based on these differences. Another area that has been brought to this is might be simply explained by our own experience of going to a doctor when we have a virus. The doctor says, okay, you have a virus, I'm giving you this antibiotic, but you must use the entire dose, for whether it's 10 days dose or whatever it is. Why must you use the entire dose? After a few days, you may feel, okay, I feel better, I can just stop using the medication. But if you do not use the entire dose, then what happens is that in the early days of using this, you kill off the weak viruses, and then the stronger ones remain. You have to use the entire dose to kill them all off. Otherwise, the stronger ones remain, and then they replicate, and their offspring might even be stronger than their parents. Some of them will actually be weaker, some of them will be stronger, and the stronger ones will attack you with greater potency. And in fact, now we know more universally that scientists are looking at the emergence of what they call superbugs, because after we've been killing off bugs for so many decades with the medication we've been using, we have been killing off the weaker ones, but the stronger ones have been surviving and even mutating into even stronger ones.
And so would we say that they've also been, if they're mutating and developing, is that also the same as evolving?
Yes, exactly, and that's precisely what's happening basically in biological life more generally. Let's take a simple example of a dog. a female dog having some babies. Among her pups, there will be some who are relatively stronger than their siblings. If a piece of meat is thrown to them, the stronger ones will scare off the others and get the piece of meat. With this in mind, naturally the stronger one will be better fed and more likely have the opportunity to breed. Not only will he have the opportunity when, or she, when it comes to having this meat, but also when it comes to breeding time. So naturally the stronger ones will be the ones that tend to leave offspring, and the offspring will inherit the strong traits from the parent. And those among the offsprings, again, you might have some weak and some strong relatively within that group. The stronger ones will tend to survive and to leave offspring. And so with each generation, you can have a slight incremental change of strength from one to another until you have one evolving with some kind of super strength. And it doesn't have to be strength only, but certain traits that are more beneficial to survival or more conducive to the leaving of offspring will continue in the offsprings and in the offspring of the offspring and so on, with further mutations either enhancing that trait or adding new traits over time.
I'm sure there's more to discuss, but we'll leave our viewers hanging and we'll follow up at our next segment. So thank you very much, Dr. Shabbir.
You're quite welcome.
Hey YouTube, we hope you benefited from this video. If you liked it, or if you didn't, let us know in the comments below. And if you're interested in learning more, check out some of our other videos. And don't forget to subscribe so you can get new videos every Monday, Wednesday, and Friday.